So to start with today, I wanted to talk about cloud storage. And in particular, cloud storage is a very fascinating topic because of the capabilities that are available when you use cloud providers. And probably the number one way to think about cloud storage is this concept of infinity. And it means that you have CPU that's effectively infinite. You have the disk I/O that's effectively infinite, and then you also have the storage that's effectively infinite. And so as a result, you can build really sophisticated solutions by using cloud companies. In particular, probably the central component to all cloud companies is their data lake. And in the data lake, this is where you would build, let's say, a machine learning pipeline, right? We could build a ML pipeline inside of a data lake. We also could build out just storage for maybe data engineering. If you're going to build maybe a business analytics pipeline. You also could do maybe web hosting. That's another thing you can do with a data lake is you could put a statically hosted website, maybe using a technology like Hugo, which is a really good static hosting technology. And all of this can be done automatically. These pipelines can be set up because of the fact that things will really grow up and down according to the requests. And as a result, it's flexible. So you can think of it as something that's always there. You can build out lots of different services with it. And the other great thing about cloud storage is, in the case of AWS, as one example, there are 11 nines of reliability. So what this means in practice is that it's probably around, I think, 10 milliseconds of downtime per year. So really the information that's available here is always going to be available because of how much redundancy. A few other things that are probably good to point out as well. If you take most of the cloud providers, they also have different pricing as well. So in terms of pricing, what you'll see is that if you wanted something that had maybe infrequently accessed data, so I'll just say IA, you can pay less money for certain pieces of storage. So it's almost like putting your personal possessions into a storage container somewhere. It'll be less money because you don't have access to it more frequently. It's the same thing with data. You can put it into these different bins. And even as well, what you can do is you can actually archive it. In the case of AWS, they have something called Glacier, and you can archive the data. So really the way that you build complex systems or globally available social networks or machine learning companies or AI companies is to first start with the data lake and start to build these capabilities on top of it. The next component of cloud storage that I'll talk about are some of the things that are available in terms of cloud storage. So what are some of the offerings? A really good example of this would be AWS. They probably have the most offerings, and they have object storage, and that's really the backbone of what the data lake is. And in terms of object storage, what you would do is put in files and pictures and things like that. So we'll just say file, maybe a image, videos, and then another offering they have is databases, and they have many different types of databases as well, which can be confusing at first. But what is useful about having so many different databases is that you can pick maybe several databases for your project. So you could pick, let's say, a traditional relational database, or you could pick a key value database. A good example of that would be DynamoDB. Is their a key value database, and I'll show that in a little bit, how useful it is to build things with DynamoDB. Another option could be a graph database. Many problems fit a graph database really nicely. So for example, social network analysis can work really well in a graph database. There's also search engines. They have Elasticsearch on AWS. So there's many different types of database offerings, and you can, in many cases, pick several of them and use them at once on a particular project. Another thing they have is ML platforms. And so the ML platforms are really designed to sit on top of the data lake and also version assets. And so they'll version the model itself and also the data that was used, so you can detect things like data drift. Additional to that, another thing you can do in terms of the storage offerings is use these ETL systems. And an ETL stands for extract, transfer, and load. And what this means is that you can actually take some kind of a pipeline and build it to do operations in a company. And this is really a common workflow if you were going to build something for business analytics or for maybe a data engineering aspect of a company, is to automatically clean the data, put it into a format that can be useful. And on, in particular, let's say the AWS platform, they have QuickSight, which is a visualization tool that works with ETL products. They also have Glue, and Glue is a automatic ETL pipeline. And then there's also a tool called Athena, and Athena can query the catalogs that are created by Glue. So it can go into, let's say, Amazon S3, keep track of everything that's in there, and then Athena, you can write SQL queries and get access to it. So not only are there the low-level primitives in the cloud, but there's lots of different offerings that are available. And I guess the other two big ones that aren't on here yet are in terms of the servers themselves. So let's just take EC2 for example. On EC2, there's really a couple primary types of storage that you would use. One is called EBS, and EBS stands for Elastic Block Storage. And Elastic Block Storage, you can actually tell it you want to have a specific amount of IOPS. And what's useful about that is that you can do high performance computing by specifically mounting a volume and telling it, let's say you want to have 10,000 IOPS per second. So you can, unlike a laptop or a workstation where you have a fixed capacity of disk IOPS, you can have almost an unlimited amount of disk IOPS using their block storage system. Now, the block storage system won't be able to be accessed by a second virtual machine. So the other solution that's available is something called EFS. And EFS is really useful in that you can mount this shared network file system on multiple machines. And these multiple machines can do things like have a common source code that they use to distribute work. It could also share data between jobs. It can grow the disk I/O as well according to the size. So in terms of offerings in the cloud, I think EFS is one of the more interesting ones. And so let me just dive into that briefly and talk about a particular workflow that you could use with Elastic File System. So the Elastic File System it's really a rebranding of the word NFS. And NFS, the network file system, has been around for quite some time. And I believe it was created by the Sun company, which used to have an operating system that was called Solaris. And the tagline at the time, I believe, was called the network is the computer. So we'll say the network is the computer. The network is the computer. And what was neat about this is that with something like a network operating system, you can do some really powerful workflows. And one example of this would be that you could have this network file system that again could go up in the storage automatically, and it also can automatically get faster, because as you grow more storage, it'll increase the disk I/O to accommodate that. And then also it can auto archive files that aren't used frequently, so you'll pay less money for it. So it has these really advanced capabilities to it. And then what it means is, in terms of a workflow, is if you launch a Spot instance, for example, on AWS, what you can do is actually mount centrally. We'll just say these are Spot instances. You could have lots of them, a cluster. Maybe you could have 1,000 Spot instances launched to do some work, and then all of them have the same mount point. And then because they have the same mount point, this really simplifies many things. It simplifies the deployment of software. There really is no deployment necessary because of the fact that you just mount, let's say, a script directory here, and then inside of that script directory, you can actually run, whatever it is that you need to do. Let's say it's a computer vision job or a machine learning job or some other operation. You can do that automatically because the code's always available. Likewise, when the job is complete, the data can also be written to this network file system. This can be really useful in that there isn't some other process like a big data system that has to be spun up. It's all implicit to the system. So the EFS really is, or the network file system really is a useful feature that is becoming more and more prevalent inside of workflows in the cloud. And in particular, there's a new workflow. Besides just Spot instances, you can also tell serverless, which we'll get into next week. You can tell serverless machines now, I believe this is a new component on AWS, that they can mount the same file storage system as well. So what's helpful about that is that you can have these stateless functions that can write their data transparently to Elastic File System. So this might be one of the more interesting ways to actually use the cloud because of the fact that it elastically grows up and down. So the other topic that I wanted to talk about next here would be, how would you build a real world data engineering pipeline using these tools? And I have an example of this here under Cloud ETL. And in particular, a real world pipeline would be something like you would, again, have the data lake here. You would maybe have a database. The database would use this serverless ETL system. AWS Glue would create a catalog, and then Athena would query it. That's the high level. But let's look at it in, and there's a video that you can take a look at there. But let's look at a real world problem that I had to build before when I was building a social network several years ago from scratch. So one of the things that happens with a social network is, how do you actually get a user to join your social network? And one way to do that is that we now know it's called something. It didn't used to be called something. It's called influencer marketing. and you partner with people who are already on some existing social network, and you get that person with a large amount of followers to post to your platform, right? And so one of the ways that you would need to first figure out who to partner with is to learn about who are the kind of people that if you partnered with these people, they would build out effectively the right signal to your platform. So this was something I built from scratch, where I would go to a third-party system and get a list of all of the people in sports in the United States, and actually around the world as well, including European soccer players like Ronaldo or other famous soccer players. So in this example, this is Joe Montana, and I have the information that he played for the 49ers, and I put this into a database. And then I have a nightly job that runs that goes into this jobs framework that I build. And this job framework would have some something that can go through and run something periodically. And most machine learning or data engineering jobs frameworks, you tell it to run at a certain interval, and then you also tell it the data sources and then the data output. And so what I would do was I created a Mechanical Turk job, and this is a way of cleaning up the data. I would ask people around the world effectively to find the social media handles, and then I would take 10 of the results, and then I would figure out if most of the 10, a quorum of them, agreed on who Joe Montana's social media handle was. Then I would create the full record. And so here would be an example of LeBron James. It says LeBron James, Twitter handle @KingJames, Wikipedia handle King James. And then it would go through and it put it into this database. And then again, I would go back and go to this nightly job, and now I could do more interesting information. So first, there's a cycle here where I would have to get a rough record that isn't fully complete, and I would need to augment it with a way to clean up the data. And that was what the first aspect of the data engineering pipeline did. Next, what I would do, once I knew what the real social media handles were, is that I could create a second social media metadata handle, and this would go through and query Twitter, Facebook, Instagram, and it would find out metadata about that particular user. So one of the things that I would look for would be how many followers that they would have, what would be their engagement ratio, and then what I would do is take that information and use it to build out a machine learning model. And how would I do this? Well, I would look at the platform that I built, and I would look at how much traffic was actually being generated. So I would then look at the signals on that pattern, on that platform, the third-party platform, and use it to predict how many page views would occur based on the users on my platform. And so what we saw here is that we were able to have a machine learning model where it would predict the page views per post. And one of the things that happened was that we were able to actually identify the right people to predict with. And so here's a good example. What happened was that using those same signals, we were able to partner with a famous NFL quarterback. Here's the logo of our company at the time. And he created some posts around the NFL draft and completely saturated our system because it was so popular. And a good example of this would be this overview. Is from a high level is you have the Amazon Mechanical Turk. It goes through and it finds the social media handles from these different platforms, and then you can see this is a diagram of that we were able to predict which are the most successful users, and the actuals were that we were able to get an exponential growth of traffic on our platform, right? And This would just be a good example of the iterative process it takes to actually build a real world data engineering pipeline. But it really starts with this, right? It starts with that you have to architect out from a high level what your system does, and often there'll be multiple loops. So there'll be the start, which will give you the raw data, and then you'll continually have to run multiple other jobs to complete the data. And this could take maybe a year. I think this took almost a year to get the data pipeline completely right, just because of how difficult it is to get fully complete data. And I think that's one of the big takeaways with building this kind of a pipeline from scratch is the difficulty in doing ETL and identifying it. And so what I can draw next here is some of the things that were edge cases that I noticed in building a machine learning pipeline and doing this kind of work from scratch. Was, what are the edge cases to building these data engineering pipelines? So one of the edge cases that comes up a lot is that it's easy to forget that the data input is the most challenging part of the problem when you're building machine learning systems. And what this means is that in the first part of building a data pipeline, if you don't have the data right, it could, on the back end, really cause a lot of extra work. And so when we were first inputting the data, we used interns in our company to collect the data, and they really didn't do that good of a job because it's a really hard job. And as a result, we would have, let's say, 50% of the records were bad records. And a good example of this would be that, let's say there was a sports player, and I'll pick one that's a really good example. In the NFL, there was a player called Anthony Davis. NFL. There you go. In the NFL, there was a player called Anthony Davis. And this player in the NFL didn't have a hugely popular career, but there's also a player in the NBA called Anthony Davis, and we know just a few days ago that Anthony Davis won a championship along with LeBron James. So these are very different people, and they have very different social media handles. So this Anthony Davis had, 10,000 followers. And the Anthony Davis in the NBA, even back then, in 2014 or something like that, or 15, he had, I think, millions of followers at the time. So the signals would be very different, right? So if I captured his data here and I put this into the machine learning system, this would give me accurate predictions about later if we wanted to partner with him. But if I mistakenly put this NFL player in with only 10,000 followers, this now causes a huge problem downstream in that now my prediction accuracy is very poor, right? So, in this case, I guess we would say this would be the mistake where it looks like the data is correctly input, but it will cause poor accuracy in the model downstream. So this is really it's a subtle problem that the only way to really solve it was the humans had to go away, right? Is that when you have humans involved in building things, that it really can cause big issues because the work is so boring. And if you're talking about, they needed to create a repository of, let's say, 100,000 users here, that the work is so intense that there are going to be constant series of mistakes. And then the results are, if what we're trying to build is a machine learning prediction model, that it really is going to have some significant problems. So what is the solution to make sure that you don't introduce these kinds of errors where you confuse the records or you switch things. Really, the solution here is actually automation. So now I'll explain the solution here. So in terms of the pipeline, the way we were able to automate it, so we'll call this fixing the edge case. So in terms of fixing this particular edge case, what we were able to do was use that mechanical Turk system. And the way mechanical Turk works, and this is really now a bigger trend in terms of getting the right data, but it's basically a mixture of humans plus technology. So here's the humans, and then we also have some kind of data augmentation, AI. We'll say this augmentation. In the case of mechanical Turk, we'll say this is MT. What it does is you could ask. It really then becomes more of a. In the fix it, this would be. We'll just call this automation. And what we had to do was create a record here of the people. So we would say, look, I want you to. We would have to tell a very specific story to the people that were asking these questions around the world. We would say, effectively go to Google and search for this person's name, search for X, and then find these three things. Find A, the Instagram handle, B, the Facebook handle, Facebook, Instagram, and then C, find Twitter, and then use this information and put it into the spreadsheet. So then we would ask 10 people. We would ask 10 people, and these would be random people, to grab that data. And then if we had 8 out of the 10 people would agree on the correct social media handles, then we would accept that record. And so we knew that the error rate was effectively zero if we were able to get 8 out of 10 people to agree. So I guess the fix here is that you really can't rely on just a human by themselves in inputting data for a machine learning pipeline. You have to have more sophisticated tools, and that's what one of the things that people are really starting to lean on, is this mixture of the humans inputting the data in a larger system with some kind of data augmentation, where you have a mechanical Turk system that can really hold it all and pull it into an API that's available for you. So that's the theoretical aspects of building things in the cloud. But what I thought I would do next here is start to build out a real world example of something that could solve some problems. And that's what I'll focus on next here, is a product that we could build right now that could solve some problems in the cloud. And so I'm going to shift gears to this project right here, which is called AWS Lambda. It's a repo. And what this is a reasonably straightforward example of how to build a serverless data engineering pipeline. So this would be much simpler than the examples I showed before, but the concepts are pretty easy to understand, and I can build this probably in maybe 30-40 minutes. So what we would do here is have a timer that gets triggered, let's say once a minute, and then I would have a database that's a key value database that lives in DynamoDB, and then I would use a AWS Lambda function to read data from this database. So this would be effectively asking for the work that I would need to do each day. I would put the data into SQS, and then from SQS I could then trigger the next phase, which is the consumer phase, and then I would perform some kind of sentiment analysis on it, and then throw that data into S3. And this is, I think, a good pattern for building solutions on the AWS platform in particular. And if you have access to the AWS labs, this is a great place to really practice these skills. So what I will do here is just build this step by step. So there is some code there, and there's some walkthroughs here that will be helpful later that you could look at. But for here, if I go to this notebook, this can walk us through the different operations that are necessary. So what I'll do is I'll open up that one, and I'll also open up AWS Lambda as well, and then I'll open up a console so that I can build this out. And we'll log into this account, and here we go. All right, so if I go to Cloud9 here and create a new environment, I can go and call this a ETL cloud environment, and then I will go through here and pick a new instance that will be spawned, and then I'll also select Amazon Linux 2, which is the newer version of Amazon Linux, and then say next step here and spin this up. This will take just probably 45 to 60 seconds to spin up an environment. Okay, got this thing spun up here. And what I will do first here is just show that what's nice about this particular environment is if I want to, I can actually build out Lambda functions inside of this environment by actually clicking on this icon, and I can build them out directly in here and actually publish them to AWS. So the first thing that I'll do though is scroll down here and show you some of the stuff you can do with a Lambda function. And in particular, this example here would be a Lambda function that could detect change, right? So let's say I wanted to build one that was an API for a vending machine. I could build out a small Lambda function and test it out. And I think I have the code here. Let's see, inside of here, let's find this. I think it's in this project. It's in here. It's called, if it's not in there, it's going to be in here. Let's see. Where is this change machine? Here we go. Here's the code. So I'll just copy this code here and just throw this in there. So I'm going to make a new one just to basically get started as a test to just show how this works. I'll say create a new Lambda function, and we'll call this change 1017, and I'll say next. At runtime, I can say what runtime I want to select. Although actually, you know what, there may be an issue because I think that this one is actually Python 3.8. So that might actually be an issue here because I don't think it has Python 3.6 on this particular environment. Yeah, I don't think Python 3.6. So I'm gonna because this wizard here wants to use the Python 3.6, I'm going to spin up a second instance that is using an older version of Python. They don't have the new functionality built into this version of their tool yet. I'm sure they'll get it in the next maybe month or so. But I'll create one again, and we'll just again call this ETL 1017. And then I'll use the older version of Amazon. So I'll use, instead of using Amazon Linux, I was using too new of a version. So I'll stay with the old version. All right, so let's spin up a second one. So these are some of the things that do happen sometimes with these cloud providers, is you have to be very careful to see how their tools work. If you try to use too new of a version of something, sometimes it just won't work because they don't fully integrate it. But in general, my experience with this Cloud9 has been really good. Just the Amazon Linux 2, which is their new operating system, it looks like they haven't fully integrated it with all of their tools yet, which is kind of weird that they would put that inside of their system as an option. But it's a great way to get very confused when nothing works, because the runtime itself that wouldn't have supported, I believe, Python 3.6. Maybe it would have, but it's not worth playing around with right now. So let's go back here again, and I'll select this, and I'll again say change ETL, and then I'll do 1017. Okay, there we got this. Now I can select the runtime Python 3.6. And then for a trigger, I'm not going to trigger anything. I don't need to have any special rules, so it can build out a scaffold here of a project for me to build a Lambda function with. There we go. Okay, so now that I've got this basic handler here, I can replace it. So I can go here and just swap this out with this particular function. And what it will do is it will look for a JSON payload that has the word body in it. And then what it will look for is the amount. So it will load this JSON payload and load this amount variable, and then swap the keys here, the amount, and figure out their correct change. And then it will return this out via a JSON dump. So if I save this, I can test it by just scrolling to this Lambda function, going here and saying run, and then say run local. And then if I type in an amount, I can go here and say amount and do, I believe I put this in a string as well. And I say, let's say $1.37. Will it find the correct change? Let's find out. I think maybe it takes a second for it to wake up. Okay, there we go. And we can see that it was able to correctly give me back that it takes 5 quarters, 1 dime, and 2 pennies. That would be the correct change for $1.37. And then I could try other things as well. But this just gives you more of like a warm-up to show you that you can build neat tools by using a Lambda function, right? And it's a pretty small amount of code. I can build out a nice example of something. So what we'll do next here now is that I'm going to build out the more complex system next, which is build this out. So how would I do this? Well, first I need to build out a DynamoDB database. So let's actually do that. So I'm going to go to the console again here and show you how straightforward it is to build a database. So if we go to Dynamo and run, look at the tables that are available. So I have one already created here, and inside of this database, we look at the items that it has just names of companies. That's it. It's almost like a Python dictionary. It's that simple. And then when I scan it, it will give me back all of these results when I query it. And if I wanted to add more things, pretty easy. I could go through here and add some new company, I don't know, Twilio or something, and add this inside of here, and then it would show up, right? And if I want to delete it, I can go through here and delete it. So it's a really useful and simple database to use. And if I want to create a new table, it's very easy as well. I can just say, new table, and just put some globally unique ID, and it would be, let's say, a string. And the reason why this has to be globally unique is so that you can know what record to pull out. So it works again very much like a dictionary in Python, and it takes, let's say, 20 seconds to create a new table. There we go, or 3 seconds to create it. And if I want to delete the table, very easy to delete it as well, right? So pretty simple system to use, but very powerful. And so we got that built. And then what's the other pieces that we can build here? So we did that. I'll build this in a second. We also need to build a queue. So I'm going to move to the queue now next, and I'm going to go to SQS. And the queue on Amazon as well is similar to other things in that this queue it's a high throughput system to system messaging, and it basically, you can't give it more data than it will be able to accept. So you literally cannot. It says nearly unlimited throughput. So you just send messages into it, and they'll be available inside of this queue. So to use it, I'll say create queue, and I would go through and put the name of the queue. Now let me just double check that there's no queues available. Okay, so there's no queue, so we'll create a new one, and I'm going to call this queue. What do I want to call it? I want to call it, I think I would call it producer. I think that is a good name for it, if I remember correctly. I can look at my source code real quick and just double check. And let's see here. This populate SQS will be, it's going to look for producer. Okay, yeah, so I'll call it producer. So let's go ahead and do that. We'll say regular queue, call this a producer. I can leave everything default, and it'll make a queue. Now I can show you how easy it is to send messages. I can say send message, hello, put this into the queue. And then if I go down here, I can say pull for message, and then here's my message. It appears, and I look at the body, it says hello. So pretty simple system. It's almost like a mail system almost. And then to delete it, I can just delete, or you also can do purge queue as well, which is available here, and it would just delete all the messages in the queue if you had 1,000 of them or something. So we got the queue created. So let's keep moving here. So we got the what components? We got database, the queue. So really, we just need to create the 2 Lambda functions, and we also need to create the CloudWatch timer that talks to it. So the first thing I'm going to do is I'm going to create this producer Lambda. So in order to do that, I'm going to look at this particular piece of code here, which is the Dynamo to SQS code. And what it's going to do is it's going to get an instance of DynamoDB, an instance of the table, an instance of the queue, and it will first grab all of the information from the database that I showed you earlier called Fang, and then it will send a message to that queue. So it'll just populate all these messages into the queue, right? So this is the send emissions. And then from the handler here, it will be able to just go through and just send messages and populate it into the queue. So it's pretty straightforward and actually easy to test. And so what I can do again here is I'll make 2 instances of this so that I can look at the source code at the same time. So I'll keep that one for the diagram, but then in here, I'll grab the populate SQS. I think this is what we want. Yeah, so I can just grab this, and we'll build a new Lambda with it. So I will go to Cloud9 here, and I will go through and make a new one. So let's make another Lambda function. We'll close all this up. So I'll say new function, and we'll call this the producer 10.1.7, and for runtime I'll select Python 3.6, and there'll be no triggers. Now there will be a role because this will need to talk to the SQS system, and so I've already created a prototype role that's like an admin role that can do anything in prototyping, and then I'll finish. So that would be an IAM role. Okay, now that this thing is set up, I can just paste this code in like this, and then you can see again, here's all the code, right? So this is use the Boto 3 Python API, scan what's inside that table, and then put that information into the queue. Now, in order to deploy this, there is a little bit of a trick you have to do that's a little bit annoying, and is that you have to actually use this virtual environment here and then install packages in a particular way. And so what I'm going to do is I'm going to cd into that directory, and then you can see that there's a virtual environment they created for me. So I'm going to use it. So I'm going to say source venv bin activate, and then notice that there's a requirements file here. So I'm going to put in my code into that, the packages that I need for this particular project. So what are the packages? It's going to need, I believe, we can just look at this. It's going to need Boto 3 JSON and then Python JSON logger, 3 libraries. So we'll say Boto 3, and I guess JSON's already in the Python library. It's also going to need Python JSON logger. So I think it's Python JSON logger is the package. And then what I'll do is I have to install this in a weird way, and then this is the way I typically do it, which is I will say cd into here and do pip install -r requirements -r requirements, or no, -r, and say the directory above here. Use that as the list of packages to install, and then also let me look at the exact command. I always have to look this back up. Is that it will say there's a certain way you do the installation, like this. You do --target like that. You do --target up. So basically put the packages one directory above me, because that's the way they want you to. So they have the main directory, and then right underneath it is where the Lambda lives, and they want you to put the packages right above it. So this is how I typically will install it. And then you'll see that a bunch of packages will populate at the same level, at the top level of the package. There we go. And now we've got that, I should be able to test my Lambda function locally here. So how would I do this? Well, I would go to the producer, right click on it, and go to run local, and it doesn't need a payload. There's nothing to accept. It'll just grab the data from the database and populate it into the queue. So if I click run, you can see that it will populate, or at least it should populate, unless I screwed up something. Let's look here. Null. Interesting. Well, let me see if I can debug this. So if I go through here, this looks like it should work. And if I right click on it, run local, not sure why this one is, unless maybe it did. Oh, there we go. So it's just the logs are not showing up. I was like, I thought this worked. It's just the logs are looking a little weird here. So you can see it's actually sending data. I don't know why the logs look weird. So how would I test this out is if I go back to SQS, this queue should have a bunch of data inside of it. And so what I can do is go to send and receive messages, and look, there's 25 messages available. And I can pull from messages, and you can see these are all the names of the companies, right, that I pulled from the database. So you can basically test this out pretty well by using the Cloud9 tool. Okay, so now that I've got that working, what I will do next here is deploy it. So if I right click here, we can say deploy. And then when I do the deploy, it will automatically put this into the AWS cloud. So this will take just a second to deploy, and then I can actually look for it by opening up the Lambda console, which will be here. And you can see the producer is available, right? And it will show me all the different things that it does. And if it's a big function, I think like this one, it won't show you the code because it's just too big. There's too much code in here, but you can actually look at other things inside of here. And one of the things that we'll do, if I just double check that the deploy, okay, so the deploy finished, is that I can now set up a trigger to run this automatically. So if we go again to the queue here, we can see that it's got how many messages? It's got monitoring. I guess we have to look from this view, but it says 25 messages available. But what I could do is I could set up a trigger that tells it using the CloudWatch system, which is, they called it something new now. It's called, CloudWatch events, that I can run this every interval. Like probably in the real world, you would run something like this once a day, but just to test it out, I'm going to run this every minute. So I think I already have a 1 minute timer here, but I'll create a new one just for fun. We'll just call this 1 minute 10:17 and just say this is a 1 minute timer. 1 minute timer. And then I can put in the rate here, which would be 1 minute, like that. And then I can enable the trigger. And what's nice about this is now it's just going to call this every 60 seconds. And so that queue will know it's working because, again, every 60 seconds here, this thing will pump out more messages like this. So if I go to pull for messages, it'll take about 60 seconds for it to run, and then this will just get bigger and bigger and bigger. So we can wait for a second and make sure that this thing is running. Looks like it's running. We can even look at the details, and I believe it will even show me here. I could even look at the target, and it will show me what it's actually calling. So it's even telling us here that it's calling this function. And I think that there's even a metrics. Yeah, I think there's metrics for this where it could show us, it could visualize how many times it's actually been invoked, which is kind of neat. So if I just added this, we should be able to see how many times it's been invoked. So it looks like it's been invoked. It hasn't been invoked yet, so it should be invoked in a second. So again, I can just kind of hang out here, wait for this, and when it gets to 30, there we go. So we see it's running, right? It's populating. So let me show you where we've been up to. We built this, we built this, and we built this, and we built this. So we've built basically the majority of the system, and now we just need to collect this data and then do something with it so we can finish off the pipeline. So what I'm going to do next here is I'm going to build a consumer Lambda that can go to the Wikipedia pages of these companies, grab that data, and then perform natural language processing on the data, and then write the results to an S3 bucket. So to do that, what I will do is go back to my Cloud9 environment, which is here, and I'm going to make a new function inside of here. So to do that, I will click this icon, say create new Lambda function, and I'm also going to just deactivate this environment and just get out of it and close this so that it's not as big, and then create this new function. So we'll call this one the consumer. So this will consume the data that's getting populated from the queue. So we'll say consumer 1017, and same thing, I'll just say Python 3.6 and go next here. And for this as well, I'll need a role because it's going to do natural language processing. So this is a big gotcha, is that you do have to make sure that the lambdas you create either have the specific roles associated with them in the IAM user, or you have an administrative role that can do everything, which for me, when I'm building prototypes, is a lot simpler to just build one role. In a production environment, it's better to specifically give the Lambda only the permissions it needs to do its job. So I'll go through here and say finish. Okay, so we got this producer, the consumer Lambda here, which has nothing in it. So I'll go to my code here, and I'm going to find my other example project, which is here. And that's going to be, we've got consumer populate, I believe it is this one. Wait, it's serverless sentiment analysis. This looks like the code. I'll walk through it in a second. And yeah, this looks good. Okay, so I'm gonna throw this into there. So just copy all this and put this into my Lambda function. All right, so again, what does this thing do? Well, what this does, I don't know why that's imported there twice, but basically what this does is that it will first use the Boto 3 API. Also, it'll use pandas, Wikipedia, and I create some logging at first to just give information inside, which is really useful actually in building a Lambda function, is that in order to see what's happening, and we'll show that in a second, it's really difficult unless you add really good logging to know what's happening, because the function is invoked in the cloud somewhere. So next up, I will get access to the queue, and you can see what it will look like inside the queue. I'll have to process these messages. So this Lambda function is going to be, if I go back to the picture here, this Lambda function, it effectively just sits on the queue. You can almost think of it just waiting, like for jobs, and it's almost like taking tickets from the queue, constantly to process them. And so it will need to process this kind of a payload. This is what will show up in the message from the queue, and so that's what this code does at the beginning. Is it gets access to it, and then after I have processed the message, I need to delete it. Otherwise, I would keep duplicating the work, right? Which is not going to be helpful. I want to grab the work from the queue, do the work, then delete the message in the queue so that it doesn't overfill. And then finally, now I get onto the work, is I grab a snippet of data from the Wikipedia page of whatever company I got. So I go in there, grab the page from Wikipedia, and then I will make a data frame out of it in pandas. So that's what this pandas data frame does. And then next up here, I will go through and create a sentiment analysis of it. So I'll use Boto 3, and I will go through and say, hey, I want to figure out some sentiment analysis. Great, I've got that working. Next up, I'll go through and apply this sentiment analysis and give this into a column. And then finally, I can write it out to the S3 storage system, which is, you can think of it as like Dropbox or Google Drive or Box or something like that, where I'm just going to put this data and put the results of this API call into there. And then the Lambda itself, this really does nothing because all the work's in the 100 lines of code above. And what this Lambda does is it will go through here and capture from the queue, process the records in the queue, and then write out the results. Okay, so we got that. We've got that pretty much explained. So I'll need to do the same thing I did before, which is I'll need to install these packages before I do the deployment. So in order to do that, I will cd into this consumer here. So I'll first go into the environment. So this is the environment section of the Lambda. It's called tilde environment. And you can see it shows the different directories. I'm going to cd into the consumer here. And then I will activate the virtual environment as well. So I'll say source venv bin activate. And then what I will do next is I will add the packages inside. So I will go to this and I can look, what does this thing need? It needs Wikipedia, pandas, Bodo, and then also Python JSON logger. So we can add all those. Wikipedia, it also needs Bodo 3, and then Bodo core, and then it also needs Python JSON logger, and then it also needs pandas. There we go. So it needs pandas. This looks good. Looks like I've got this thing cooking here. And from the next step that I would do would be to install it. So what I would do again is cd into this directory and then do that same technique that I did before. And I could even just look at history and copy. This is kind of a neat thing you can do, is notice I already did this really complicated command before, which is this. So I can just run it again. All right, so I can just say, and in fact, this is a neat trick you can do, is you can actually invoke the line itself. So I can just say, it's on line 7, right? If I scroll this up here, I can say, I want to run line 7 again. So I can do exclamation point 7. So this means invoke that line again. There we go. And I can install it again. All right, that looks like that works. And now to deploy it, I will go to the consumer and then right click and then do a deploy. And that should take maybe like 20-30 seconds to deploy this. And it will again appear as this is deploying. I can look over here and go back to the lambdas, and it should, there we go, consumer, that it will populate here. And if we go back to, if we go back here, when it's done, this will, when it's done deploying, this will get changed. And so we can see, okay, there we go. It's done. And if I refresh this, this should go away. It'll probably say too big. Yeah, so it pushed all the code. So now I have to add the trigger. If we go back to the diagram, this has to be told to listen to SQS. And in fact, if we look at SQS here real quick, the messages will be way over 30, right? Because every minute it's been populating. So if I refresh here, let's see what it comes up to, 85, right? So it's it's full of messages. We need to populate it or depopulate it. So to do that, I will just say add trigger, and then it'll ask me what kind of trigger I want to set up. I want to do, in this case, an SQS trigger, and I can say, I want to call the Lambda every message just one at a time, and I want to grab a message and process it. And so I will say you need to tell it what queue. There's only one queue, so that's the one that it'll process. And then this should, once it'll take a second to set this up. So it's creating right here. As soon as this trigger is set up, it will really quickly drain the queue and just pump a bunch of messages out because it's in theory completely asynchronous. So it could have a tremendous level of concurrency that's available. So let's go through here and do this. And pull this down. There we go. Here's my queue. Okay, so it's ready. Now that this thing is ready, what I can do is actually go back to the queue and see how many messages are still available. And so we should see, look, it was very quick. It's already populated 85, or let's see here. It should be grabbing these messages and pushing them out. So this will drain the queue really quickly. And what we can do now is if I go to this consumer Lambda function and I go to monitoring, I can actually look at the logs and I could just see exactly what this system is doing. And if I go down here, we can go here and look, you can see exactly the steps that it's doing. It's going to Wikipedia, it's pulling some data, then it's going to, get some other information. It's gonna do the natural language processing. It's deleting the queue. It's creating data frame. All this stuff. So that's great. It's got this stuff working here, which is awesome. But how would I also see the message? Well, if I go to the S3 bucket, and I think it's called, I'd have to look at the code actually. What did I call the bucket here? Was bucket, what was called Fang? Yeah, Fang sentiment. I have a bucket called Fang sentiment. And so if I go to that location, which is here, and I look at Fang sentiment, this bucket should have new entries. And I can refresh this by last modified, and that's today. And we can see here these different sentiments. So I can just download one of these and just look at it. So I can just go download. And then because the Cloud9 environment makes it really easy to collect data, I could actually just go here and say file open, or file upload, and just upload one of those and take a look at it. So I can go here and go to desktop. Here we go, Netflix, and select it. And I could just look at it right here, just say open. There we go. And you can see the results is that it has the Wikipedia snippet, the sentiment, it has the text from what it grabbed from Wikipedia, and then it was able to classify it as neutral, right? Because that's just a name. It didn't find anything else. So you could do more sophisticated pipelines than this, but the concept again is I think fairly powerful in that this is really a template that you could, maybe you could do find all the entities in a phrase, or translate something from English to Chinese, or from Chinese to English, or do both. Translate it, then do sentiment analysis on it. All kinds of things you could do with this type of a pipeline that are available using the serverless data. So what I'll do here, this is always a good idea once you've finished something like this, is to clean up the resources. So I'm going to go back here and I'm going to go step by step and delete these resources. So the first thing I'll do is go to the producer and I'll purge this queue. And you can see that, in fact, all the messages were already processed because it processes them very quickly. And, I have to say purge, and we'll purge this queue. So now the queue goes away. We've deleted that. The next thing that I would delete as well would be go to this Lambda function, and I would delete this. So I'm going to go to the producer and the consumer and delete them. So I'm going to click on this and I'm going to say delete. So this will delete this Lambda. I'm also going to delete this consumer as well. Just delete that. Might as well delete the change thing that I created earlier as well. Delete that. So we've pretty much deleted everything that we need to delete, and we're clean. We've cleaned up the work, and then we won't get charged, because it's actually very easy. If we look at this diagram, if I left this running for a long time, it would actually, this would probably be the thing that would generate a lot of charges from AWS, because eventually we would run into those limits. But also the Lambdas themselves would generate log files that would appear, and then eventually the log files you could get charged. I don't think a lot of money, but you would definitely start to generate charges. So it's good to clean these up. The other thing that I could clean up as well was the CloudWatch events. So if we go to CloudWatch event bridge here, I could actually look at some of the rules. Let's see here. Where were those rules available? Create rules or rules. Go to rules. Yeah, and you can see there's a bunch of rules. I can just delete this as well. I could just clean this up. And these are just some other rules that I had that I don't need. I can just clean this up. But in general, it's better if possible. It's like cleaning your room. Is if you can remember to clean stuff up, then you won't have weird things hanging around that you're not sure what they do, or like in this case, a bunch of these look like they're all things that I could delete that I probably should have deleted a long time ago. But in general, it's better to do it at the beginning. So